So far, we've established the domain of rational functions, and then we've also looked at certain things that may happen where we might be able to simplify or rewrite a rational function, but the domain from our original function still applies. Now let's take a look at what happens when we actually graph these functions, where maybe we get a factor that divides out. So let's consider a function. Let's consider f of x equal to x squared minus 6x plus 8 over x minus 2. We know from algebra and earlier in this video that x minus 2 is going to give us an issue with the domain of this function because we know the denominator cannot equal 0. So I have to exclude 2 from the domain. And I'm going to go ahead and establish my domain before I do any kind of rewrite as the set of all x such that x is not equal to 2. And that's going to be very important whenever I start applying some algebra to see if I can't rewrite or simplify this particular function. Well, when I look at this function, I realize that the numerator will factor for me. So let's go ahead and factor the numerator. And we can see that it factors as x minus 4 times x minus 2 all over x minus 2. And I now have this common factor of x minus 2, which can be divided out. And so I can say f of x behaves like the function x minus 4. And again, I still have this domain restriction that x cannot equal 2. And so what I have here is f of x is a linear function, or it's going to behave like a linear function x minus 4, except at x equals 2, because that's where my f of x, this initial function, is undefined. So hopefully we can recall from algebra that whenever we graph functions like this, so here's my x and y axis, or x and f of x axis, I'm going to graph the linear function x minus 4, which we know has an intercept at negative 4. And it has a slope of 1, so I'll go up 1 over 1. I also know that it's going to have an x-intercept at 4. But something very interesting is going to happen here. So I know I can kind of just portray my slope here, and I can start graphing this function. But when I get to x equals 2, this place where I have restricted the domain, even though I've got this linear behaving function, I have to put what in algebra you called a hole in your graph. And so I'll kind of go up 1 over 1 and place that hole there. But I know that I'm going to have to remove x equals 2 from my domain, and then I can proceed graphing this linear function. And so there is my graph of f of x, which again behaves like the line x minus 4, except at x equals 2. So I'm going to go ahead and state that and say f of x graphs like the linear function. Y equals x minus 4, but has a hole in the graph at x equals 2. Because that's what we had to restrict from our domain, and so that's why there's a hole there. And it's actually where that hole is at that we're going to be very, very interested moving forward when we actually start talking about calculus. And so it's going to be very important for us to understand why that hole is there, but that maybe we'll be able to say some things. And that's a big part of our first major unit of AP Calculus.